Well, hi everybody. There was one more problem in our notes on Monday that we didn't work through, and it's a little bit tricky to set up, so I wanted to work through that one with you as well, or at least give you the chance to see how it's set up, because you'll see problems like this in your homework. So here's what we've got. A father, while driving his car, and his son on a bicycle, they're going to work together to complete a paper route. And when they work together, it takes them 35 minutes. Now, this problem might sound familiar because if you look in your notes in section 7.7, we looked through problems just like this. But back then we knew either the father's time or the son's time. Here we don't know either. But we do know that it takes the son 25 minutes longer to do the job alone than his dad in the car. And that makes sense. He's only got a bike. So the question is, how long would it take the son to do the route on his bicycle if he worked alone? We know that together they can do it in 35 minutes, but we don't know how long it would take either one of them to do it alone. Well, if you go back in section 7.7, we did a bunch of problems like this, so if the general format doesn't look familiar, go back and review that. But in general, if you take the rate at which a job is done times the amount of time spent doing it, that will tell you how much work is completed. It's kind of like distance rate time. The speed of your travel times the time spent traveling would tell you how far you traveled. It's the same idea. So back when we did these earlier, we set up tables to organize our information. We'll do that here too. We've got a father and a son. Each one has some amount of time necessary to complete the job. That results in a rate at which each one does the job. They're both working for some amount of time, and each one does some amount of the work. So if we start filling this in, it's going to look like this. Let's focus on this. So we don't know how long the father will take to do the whole job by himself. We're going to call that X. We don't know how long the son would take either, but we do know it's 25 minutes longer. So however long Dad took, well, Junior's going to take 25 minutes longer than that. Now the rates are the reciprocals of the times. So if the father would have taken, let's say, 60 minutes to do the job alone, well, then he can do 1/60th of the job per minute. So the rate is always the reciprocal of the time necessary. And again, if you look back in the examples in section 7.7, that might refresh that idea for you. Now we do know that they're both going to work for 35 minutes to get this job done together. So each one works for 35 minutes. And as our basic formula says, the amount of work done is the product of the rate times the time. So if we take our rate for the father times the time, we get 35 times 1 over x, which we can simplify and simply call 35 over x. The same thing is true for the son. His time was x plus 25, so his rate is 1 over x plus 25. For 35 minutes, that means the amount of work done is 35 times 1 over x plus 25. Or if we simplify that, we can simply say 35 over x plus 25. Now here's the key. If they work together, what is their combined amount of work done? Well, they're going to complete one paper route. Or in other words, if we add those two amounts together, the father's work done plus the son's work done, together we get one complete job. And there is the equation we need to solve in order to answer the question. Okay, now if that makes sense, move on. If that's not so clear, go back and review and how we did the problems in chapter 7.7. You'll find some that are very similar. And even if you want to, go back and rewind the video here just a couple of minutes and go through that explanation again. And if it's still not clear, why, swing by the Math Center and I can work through you with this if I'm in there. So let's go ahead and solve this equation. Now we want to clear out that fraction, right? So your LCD is x times x plus 25. So we're going to use that LCD to clear out the fractions. If you do that, you'll get a bunch of canceling. In the first term, the x's will cancel, and you have 35 times x plus 25. In the middle term, the x plus 25 will cancel, and we'll be left with 35x. And on the right side, nothing cancels, so we just have 1 times x plus 25. So there's our new equation, all free of fractions. Clean that up, get it in standard form of a quadratic, and we have x squared minus 45x minus 875 equals 0. That's a nice clean little quadratic. You can solve that however you want. Factor, yeesh, yuck. Or use the quadratic formula are probably your best options. And if you do that, and I trust that you can plug that into the quadratic formula, you get two solutions for x. Either x is 60 or negative 14.7. Well, we can't have a negative time to do the job, so we can forget about that negative solution. So our value of x must be 60. Or in other words, it takes the father 60 minutes to do the job on his own. And the answer to our question, how long does it take the son to do the route? 60 minutes plus an extra 25 longer. It'll take the son 85 minutes to do the job. All right. Well, hopefully that refreshes your memory. Like I said, swing by for help if you still have trouble with that. We'll see you on Thursday.